Hi, Zeal Academy, and welcome. Today we're doing another project for day 2. On day 2, the God said, "Let there be clouds and seas." So he made that expanse. So we have an expanse, but we're talking about why is the sky blue? So we're gonna make a project. But in that, right? It's a good question. Why is the sky blue and so is the water? So we're gonna figure out why the sky is blue today, and then we'll do another project on the levels of the water. So we gotta figure out what God did on day 2, and instead of just the expanse, we're gonna get into certain questions about the expanse and the separation between one water and the other. So today, the question is, why is the sky blue? So the sky is the colorless light from the sun is actually white light. What does that mean? It is made up of all the colors: red, orange, yellow, green, blue, indigo, and violet. What does that remind you of?
The rainbow!
The rainbow! That's right. So we have
Red, orange, yellow, green, blue, indigo, and violet.
That's right. So it's all mixed together. When all those colors are mixed together, if you've ever been on stage and you have a bunch of lights in front of you, what colors are those lights?
Red, yellow, orange, green, blue, indigo, and violet.
That's right. Now the only one that's white is a spotlight. But everything else is all those colors. And then what happens? Does it look like you have all those colors on you? No, it looks like it's just white. You know, you have a big light on you. But in reality, it's all those colors mixed together. So in light, all colors make white. Light bends when it passes from one medium to the other. And I have this jar right here because I'm going to show you what happens between one expanse, which is the air, and the other expanse, which is the water. Now we're gonna put this straw in there. We're gonna see what happens to it because it changes, light changes when it goes from air to water. So pretend that the straw is light. Okay, so we're gonna put it in. What can we observe? Take a look. A real good look at what happens to the straw.
It looks kind of funny.
It looks funny. Why does it look funny?
Hey! That part is thin, and that part is thick.
So it expands. It looks like it's swollen, right? Okay. Then what happens? What else can you see? What happens at the expanse?
At the line,
Yeah. What happens at the expanse?
it looks like the straw is not at a line.
It looks bent, doesn't it?
It looks bent.
That's right. So light bends when it passes from one medium, like air, into another medium, like water, which has a different density. There's two different things that we have going on here. So this bend of the light is called refraction. Can you say that?
Refraction?
Refraction. Refraction is the different colors are refracted by different angles because they have different wavelengths. As a result, when white light is refracted, that means that bend, it is separated into different colors known as the dispersion of light, meaning it goes into different ways. That's why we see it swollen or like
Bent.
bigger than what it really is, because it goes into different directions. Remember how we talked about rainbow and all the colors?
Yeah?
Okay, so a rainbow is an excellent demonstration, aside from God's promise, of the dispersion of light. That means when, you know how this one gets swollen? So light, when it comes in, it just goes. And it makes a rainbow. So after or during rainfall, when the waters mix, the light doesn't have its proper activity. The light hits the water droplets in the air when it's raining or right after it rained, and at the right angle. And then another way to see the spectrum of colors that compromises the white light is by placing a glass in the prism under a strong light. The air droplets in the air acts like that prism. So that's when the light bends from its natural state, and then we get to see the rainbow. It's called Rayleigh scattering. In the air, there are many tiny air molecules. These molecules are very, 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 very small. So small that we can't normally see them with our normal eyes. We have to see them through other ways. Even though the air is full of them, billions and trillions, on a clear day, sunlight passing through the atmosphere is scattered by air molecules. That's how we are able to see sunlight. Okay? This scattering effect is called Rayleigh scattering. Scattering is stronger with shorter wavelengths among visible colors. The blue-violet end of the color spectrum has the strongest wavelength. So what color is the strongest wavelength that we can see? Blue. So the blue-violet colors are scattered more than the red-orange colors. The cooler colors versus the hotter colors.
What do you mean cooler and hotter?
Well, what do you think of when you see blue? Do you think it's hot, or do you think it's cold?
Hot, cold.
Well, hot because this is more on the yellow side. So which is a warmer color. Yellow, orange, and red are warm colors, and blue, green, and purple are the cooler colors. So although violet is scattered more than blue because its wavelength is shorter, our eyes are more sensitive to blue. So that means we see more blue, okay, than purple or violet. Okay, this is why the sky is blue during the day, because we can see it. To summarize, the sky is blue because the blue color inside the sunlight is scattered more by air molecules and is perceived better by our eyes. So it has also a connection with our eyes. So now that we figured out how light works and the difference between the bending, how it bends and reflects, we're going to go do our experiment with water and a little bit of milk, and we're going to see how light changes from white to blue. Hi everybody. Okay, so now we're going to do the experiment. All right, so we have, this is our Y, okay? So the reason why the white suspension turns blue, what we're talking about, this is a white suspension, and then we're going to turn this light, and it turns what color? Blue? Blue. We're going to put on our towel, and we're going to see it in darker light. Ready? Get under. Whoa. It's darker, doesn't it? All right. So the reason why the suspension turns blue is similar to the reason why the sky is blue. So the sky is blue because of Rayleigh scattering. Because of the light by small particles, the intensity of the scattered light depends on the wavelength of the light. Remember, the wavelength was stronger in purple than the blue, and that's why we're able to see the blue instead of the red and the orange and the yellows. Okay, so the shorter wavelength, the stronger the scattering. So like the sun, the white from the flashlight is also made up of all the rainbow colors. Did you know that? So don't necessarily look into the flashlight, but in there's a little light bulb, and in that little light bulb, there's all the colors. So when it turns on, boom, we've got white light. Remember, all the lights on the stage?
All the colors?
It's all the colors. In light, all colors make white. In light, all colors make white. It rhymes. Therefore, blue light, which has a shorter wavelength, than most other rainbow colors is scattered more than the suspension appears blue. So the blue is what we see, but there's all sorts of colors in there. But remember, it has to do with our eyes.
But the
And the
color's
wavelength.
white.
It's white because we have it here white so that you can see what the light does. When your eye's seeing white and you have the light here and it hits, it's blue because of the wavelength is shorter and we're able to see the blue. So in light, all colors make white.
In light, all colors make white. That rhymes.
So we see blue. So if the light comes in and the wavelengths are expanded and we are able to see certain colors, this color that we're going to see is blue. So if you look up in the sky, which is what we see blue, is because that the sky, the particles and the molecules and everything else that's in the sky covers up all the other colors and we are able to see blue. That is why we use the white, because we have clouds, we have all these other things that make up, we're going to pretend that is the white. When the light hits it, which is the sun, which is all the colors, what we see is blue. So is the sky necessarily blue?
All the colors.
No, it has all the colors, but we can only see
Blue.
blue.
It has all the colors.
But in reality, with all the stuff that's in the sky is really clear. It's like the jar.
The jar.
The sky is the jar, the clouds and particles and molecules and everything else that's in the sky is the white. It's like a canvas. And then the light, which has all the colors, is the sun. And what we see is blue.
Blue.
And it does also a reflection in the water. So the water acts like a mirror. Everything else is in the sky. The light comes in, it bends, expands, and then we see the rainbow when it rains, when the skies mix, and we see the color blue. So it all has a part in becoming blue skies. Now, do you understand why the sky appears blue? We hope you like this experiment, and there's more to come on our Day 2 adventure. Have a great and wonderful day. God bless you. Bye-bye.